Hello everyone. In this video, we are going to discussing about the shear modulus or modulus of rigidity. Shear modulus or modulus of rigidity is the express the relationship between the shear stress and the shear strain. In the previous lectures, we have discussed the modulus of elasticity, which express the relationship between the normal stress and the direct strain, which means within the elastic limit, stress is directly proportional to the strain and stress equal to capital E into strain. That capital E is the modulus of elasticity. Similarly, here we are going to discussing about the modulus of rigidity, which is the express the relationship between the shear stress and the shear strain. So first we will see the what is the shear stress and what is the shear strain. So shear stress is the one which acts parallel or maybe tangential to the surface. And one more thing is this shear stress exists between the parts. Equal and opposite forces on each other laterally in direction to the tangential their surface in contact. So in the diagram we have to observe that one. Here we are applying the equal amount of the shear stresses, so which is the parallel to the surface. See, here we are applying the equal amount of the shear stresses parallel to their surface and opposite in direction. See, one is the right hand side, another one is the left hand side. So equal amount of the shear stress and opposite in directions and applying the parallel to the surface at the top and bottom surfaces. So next one is, if we are applying the direct stress, so which means it may be tensile or may be compressive. So the deformation will be occur change in the length. So in the previous lectures already we discussed, for example, applying the tensile force I am applying, the body it will go for the elongation, and when we are applying the compressive forces, the body it will go for the contraction. So this is already we have discussed. Yeah, let's see. So due to the direct stresses, which means tensile or maybe compressive stresses, the body will go for the deformation. That deformation in the terms of we are calling it changes in length. Similarly here also, due to the shear stress, the body will undergo the deformation. The deformation is occur in the terms of the change in angle. See here, when we are applying the shear stress, that is the tau, the body will go for the deformation. That deformation is the in the terms of the angle. So this is phi. So this deformation, that is the we are calling as the shear strain, and the stresses, shear stresses, we are representing the tau. So now we will see the find the relationship between the shear stress and the shear strain. So in the diagram we have to observe that one thing. So when we are increasing the amount of the tau value, obviously it will be effect in increasing in the shear strain. So when increasing the tau, obviously this angle will be increased. So which means, so within the elastic limit, so shear stress is directly proportional to the shear strain. So which means tau is directly proportional to the phi within the elastic limit. So from this one we have to write down that one, the tau equal to G into phi, or also have to represent the tau equal to capital N into phi. Here G and N are we are calling as the modulus of rigidity. Some textbooks it will maybe give the notation for the modulus of rigidity is the G, and some other textbooks it will give the notation for the modulus of rigidity is capital N. And here phi equal to shear strain. So now what is the modulus of rigidity mean? That is the capital G equal to the tau by phi. So observe in the tabular column, so which represents the modulus of rigidity for the different materials. For aluminium 26 gigapascal, and aluminium alloys it will be range is the 26 to 30, and the brass is within the range of the 36 to 41 GPa, and the bronze is 36 to 44 GPa, and cast iron 32 to 69 gigapascal. Similarly for the copper 40 to 47 gigapascal, and for the steel is 75 to 80 gigapascals, and the wrought iron is 75 gigapascal, and the rubber which having the very low value, it may be nearly 0.0002 to 0.001. So thank you.